Hello and welcome. In this video we want to do a question related to velocity, instantaneous velocity, derivative, and interpretation of derivative. This graph shows the position of two runners A and B who run 100 meters in total and they finish in a tie. As you can see, they run 100 meters and they finish the run in 20 seconds and they finish in a tie. Explain and compare how they run the race. If you notice to runner A, he runs at a constant velocity. So for runner A, we claim that runner A runs at constant velocity. But how we know this? When we have position time graph, this given graph shows the position of each runner over time. When we have position time graph, the slope of the curve shows the velocity. If we look at the runner A curve, basically it's not a curve, it's a line, but we can name it curve. The slope doesn't change because it is a line, and when we have a line, the slope is always the same. This means that the velocity of runner A is always the same because the slope of a line never changes. A line is basically a curve that its slope never changes. So runner A runs at constant velocity because the slope of the function, slope of the position function, of the position time function or position function is always the same, is constant. This is for runner A. But for runner B, as you can see, the slope changes. At the beginning, the slope is very small. Gradually the slope increases. Especially at the end, the slope of the position function for runner B is greater than the slope of the position function for runner A. So basically, at the beginning, the velocity of runner A runner B is smaller than runner A. Gradually he increases his velocity, and at the end his velocity is even bigger than runner A. That's the reason they finish in a tie. So regarding runner B, we can say it this way. For runner B, he or she starts slower compared to runner A. Then gradually he increases his velocity. Gradually he or she increases his velocity or her velocity, and at the end the velocity of runner B is greater than the velocity of runner A. Why at the end his velocity is bigger? There are the tangent lines at the end of the run, not exactly at the end, even close to the end, somewhere like here. If we draw the tangent line here, compare the slope of this line with this line, which is for runner A, the slope of this one is obviously bigger. At what time the distance between them is the greatest? Attention, this graph shows the position of each runner. At the beginning, they are at same point. Because at the beginning, the velocity of runner A is bigger, the distance between runner A and runner B, the distance between them gradually increases. But at what time the distance between them is largest? I can say somewhere here, the distance between them is largest. We can say at 9 seconds after the beginning or 10 seconds. So, at what time the distance between them is the greatest? Almost we can say at t equals 9 or 10. At 9 seconds, the distance between them is greatest. I hope this is clear for you. And at the end of the run, because they finish in a tie, again they are at the same point. The distance between them is 0. Finally, at what time do they have same velocity? As I explained before, at the beginning, the runner B is slower. At the end, the runner B is faster than runner A. At what time they have same velocity? Velocity is a slope of position time graph. We have to look for a point on this curve that if we draw the tangent line at that point, the slope of the tangent line equals the slope of this line here. Obviously, for example, something here is not right, because if we draw the tangent line, a slope of this is not equal to a slope of this. So I think my estimate is somewhere here at 9 or 10 seconds. If we draw the tangent line here, as you can see, almost the slope of this line is the same as the slope of the line. And this shows that at this moment, their velocity is the same. So at what time they have same velocity? Again, we can say at t equals 9 or t equals 10. So at t equals almost 9 seconds, they have same velocity.